The following video is a recording from the Urban Forest Climate Resilience Workshop held October 3rd, 2024 by the Nature Conservancy as part of the Louisiana Tree Resilience Program. This workshop was offered free to the public thanks to funding from the USDA Forest Service. We are happy to offer recordings of these sessions to make the information presented readily available to all. The following video is owned by the Nature Conservancy and should not be reproduced or distributed without our consent, and the content and information presented by each speaker is owned by them and should not be reproduced without their consent. Thank you.
Josh is a business development manager for the Davie Resource Group's Environmental Consulting Division, and he does sometimes prefer the title of theoretical arborist, though. He's worked with Davie for over 20 years and currently focuses on providing innovative and technical solutions for communities, nonprofits, commercial clients, and state agencies throughout the U.S. and internationally to proactively and sustainably manage their trees and other natural resources. He has worked as a traveling inventory arborist, climbing arborist, adjunct professor, and has held numerous volunteer positions in local, regional, state, and national nonprofit organizations. Josh graduated from Southern Illinois University at Carbondale with a bachelor's in forestry resource management, is a certified arborist, municipal specialist with the tree risk assessment qualification, a graduate of the Society of Municipal Arborists, Municipal Forester Institute, and has hugged dozens of national champion trees. I will say he is been a large component of the Nature Conservancy's larger tree resilience program. And so I have seen him on many a Zoom call, and I am so happy that he's finally here in person and hear him talk. So welcome, Josh. Oh, yeah. So should be good to go.
All right, well, thank you all for that. And Amanda, major kudos for doing a nice walking tour right after lunch. I've never seen that before. And normally when you get the first presentation after lunch, y'all are asleep. So thank you for that. Yeah, so I'm really excited to be here. Like I said, I've been working with Amanda for over a year, watching those tree slates in Louisiana take off. I will admit I have lost my adaptability for this heat that you all have. I live in Vermont right now. When I got on my plane yesterday, I was wearing a jacket. It was 50 degrees. But yeah, I used to joke that I like to call myself a theoretical arborist because I tend to get involved in a lot of kind of what if scenarios. But I think I'm adopting the new title of futurist arborist. So I'm kind of workshopping that. So you let me know how that goes. So one of my passions is the intersection of trees, people, and technology. One of the reasons that I love urban forestry is I love the impact that it has on people. And I've been really excited in the past decade to watch a lot of technological advancements that come into our field. So that's what I'm really going to be talking to you about today. So I'm going to share some of the why, and then I'm going to share some of the how and where it's at. Also, I've never been to an event before where somebody printed off all the slides. So that was cool. This is a QR code to the presentation as well, if you want to download it for your own use. You don't have to do it now. I have it at the last one. So if you want to wait and see if it's worth it, you can do that. I will. I changed it an hour ago. So the one you're looking at is not quite the same. It's very close, of course. But yeah. So with that, by PowerPoint. Let's go. Okay, so I have to say. I really don't think as artists or as urban foresters, we have to worry about technology replacements. But I do really think you should be thinking about if I don't use this, somebody else is going to, and then you might be replaced by someone that is using technology to some level. I think this goes to even using a smartphone. You know, if you get a call from a client to go look at a tree and you are not able to get there because you don't have Google Maps, you might not have a job. So just think about it from that perspective. And, you know, we heard earlier from your state forester about the concept of plant the right tree in the right place. That is a critical role in what we do as urban foresters. What I'm trying to do is move the conversation a little bit like what Andrew set us up really nicely for, is the idea of making the right decision at the right time on the right tree. We have limited resources, we have limited time, and the decisions we make matter. So when you make a decision to prune a tree, remove a tree, plant a tree, you know, it's a generation before we know if we made the right decision or not. So really having that capability. So like I said, here's what I'm going to talk to you about today. This is kind of my outline here. I'm going to talk a little bit about the why. Then we're going to some technology around individual trees. Then I'll talk about technologies that relate to urban forests. Then I'll kind of wrap it all up with a brief conclusion. So Amanda did a great job this morning talking to us. And she joked about like, if I didn't scare you, or like if you didn't scare us, or if I didn't depress you enough, like the world sucks and good luck getting trees to grow. I appreciate that, but I did want to alter a different perspective. And this is a book that I don't really, I read it. It's called The Future We Love. And it is a conversation between Dalai Lama and Greta Thunberg on climate change. So, you know, I thought it might be a real positive, uplifting future. It's really not. But the most important thing that I got out of it is the concept of feedback loops. And Amanda said this as well, that, you know, the climate is changing at a rapid rate. And what is happening is it's really centered around feedback loops. So warmer places are getting warmer, wetter places are getting wetter, drier places are getting drier. And, you know, if you spend enough time in the arboriculture, urban forestry world, you'll really start to appreciate the microclimate that happens in our urban environment. So it's something I want you to kind of think about is how, okay, the Gulf of Mexico is warming, like it's empirically happening. You can't do much about that, you know? But what you can do is reduce the temperature in your urban forest. You can reduce the temperature in your backyard. You can help intercept stormwater in a rain garden. You know, there is micro sites that we can positively embed that, if we do them at scale, can have and will have a positive effect on our environment. And you can reverse those feedback loops. So just because you have a drought happening right now in Louisiana doesn't mean it has to always be that way. If we plant enough trees and we take care of enough trees, that can influence the weather and the environment around us, and it's proven. So think about that. I won't spend any time on this, but I will just show it that, you know, Amanda mentioned that our planting zones are changing and they will change. So again, thinking about your microclimate, I don't know that I would go start planting all of Mexico's trees in Louisiana, but in the right spot that you know that they could work, start trying, basically what I want to say. And don't be surprised if the trees that used to work don't work anymore. So as it relates to climate change and the concept that, like Amanda said earlier, the climate and the environment is changing faster than our trees evolve. And without assisted migration, we have this challenge. So what I like to point out is that our technology has changed as well. So we're specifically talking about like tree assessments. For the oldest tree inventory I've been able to find is 1931 from a community in upstate New York. And, you know, pen and paper based. Worked really well for a long time. And then computers got invented. We started using computers to do tree assessments. And then GIS got invented. So we started using GIS. And that's been a really good tool. But now we have even more advanced tools. I'm just going to spend some time talking about LiDAR and photo interpretation and some artificial intelligence and machine learning. You know, when I think about these tools, if you were to ask me to do a tree inventory these days, it's really, really hard for me to envision you saying, hey, Josh, can you come out and do a tree inventory for me? And I want you to do it pen and paper. Like, it's really hard for me to think about that. 99.9% of inventories are all done GIS based. And it's because it's a faster tool, it's a better tool, it's a tool that we can share with other organizations when we're trying to make that conversation on trees with assets. So that's where I do believe this technology we're embracing now is going. There will be a point that GIS isn't good enough anymore, and we want more precise, objective information. And why is this happening right now? All industries, basically, the software and the hardware constraints have gotten this inflection point where we can actually use it now. So the ability to map existed for a while before we were actually able to bring it into the field and map things. We had to wait for our computers. I can remember doing a GIS inventory in the city of Indianapolis in the early 2000s of a home pilot. Anybody here know what a home pilot is? And I had a sleeve of SD cards. Like, I'm not kidding, I had about 75 SD cards because the memory wasn't big enough to hold the information of what I was trying to collect. Now that's a thing of the past, right? Like, so you get to this inflection point, and that's where we're at right now, where technology, bandwidth, hardware, software has finally gotten to the point where we can embrace using some of these real big data models and this real intense data collection. And Andrew talked about this. He hopes he's wrong in some of his scientific studies, right? Like, science has changed, and our management approach to things needs to change as well. And I'm talking to you as arborists. You know, I can remember when I first learned how to climb trees. The old foreman used to tell me of climbing ropes, 3-strand, and skimming up trees. You know, and I look at him like, you are crazy. I can't believe you're still alive. You know? When I talk to my kids about, you know, opening PDFs, look at me and they're like, what are you talking about, Dad? How can you not do this? So my wife, I definitely married up in this world. I have a beautiful position as a wife, and we love to have the stories about how our arboriculture really is very close to medicine. And when I was telling her about this evolution of our technology, she goes, you know, that sounds a lot like breast cancer. And back in the early 1900s, you know, when they first detected breast cancer, they didn't have a treatment for it. You know, it just was what it was. And then it wasn't until the late 60s that they started being able to start removing pieces of breast tissue. And then finally in the 80s, they started coming up with this idea of testing and examinations, and then started treatment, selective treatment. And now it's really in depth. You can get 3D mammography so you can avoid interventions a lot earlier. Our arboriculture is no different. You know? John Davy, when he started our company in 1880, he founded it on the science of cavity filling with cement. You know, like, that was the basis. He wrote a book in 1901 called The Tree Doctor. He went around selling it hand to hand, doing that to estates. We know that's complete garbage now. Lots of arborists are still pissed because they're ruining chainsaws. So let's talk a little bit about our current method of evaluating trees. I got a couple slides here, and this might make some of you all a little uncomfortable. That's good. If you're not uncomfortable, that means you're not learning, right? So embrace me, all right? So our current process of doing an inventory or doing assessments, right? It's field-based. It's an arborist going out and looking at a tree, and then it's plotting a tree on the map somewhere, right? What's the challenge with this? Well, inherently, it's very slow. You have to walk to every single tree, whether there's a tree or not. I always call it a giant Easter egg hunt. You got to go around and find trees that people don't know if they exist or not. It's very slow to enter the data. A lot of pink lists. Sometimes you're limited to certain weather. Every time you introduce another person to the team, you start getting variability in the data collection. So you start having increased issues of quality control and quality assurance. So it's just a very slow, very error-prone, and a subjective approach to doing an assessment. And when we do that, we're walking tree to tree and programming our computers, and we are getting the same data on every single tree, whether it needs it or not. We're doing a risk assessment on every tree, whether it needs it or not. And when we get to the tree that actually needs it, we are so far behind schedule, we have to hurry up and get to the next tree. We're not actually doing a lot of in-depth, deeper analysis on a tree that we should, because we have to spend all this time, saving time on every single tree. Another challenge in the urban forest is most communities I talk to are very reactive in their management program. Can anybody identify with that statement? So we did a study in Largo, Florida, looking at comparing the city's 311 calls to the actual health and condition of their urban forest. And you find out that you're driving past so many more high-risk, high-maintenance trees to get to that one that somebody called about, that obviously it's inefficient, but you're also leaving a huge amount of exposure and not proactively taking care of your forest as well as you could. So when you have this reactive approach to it, it disservices everybody in the community. I mentioned that when you're doing the inventory of sensitivity, and I was hoping that Andrew mentions Dr. Stephen Russiner. He is a German scientist, and he is one of the foremost researchers on tree risk. He actually helped invent with Frank Rand the resistograph and tomography. So every year for a week at our institute, we have what's called Biomechanics Week. And we bring in the Bartletts and the researchers, Andrews, Rich, all these researchers from all around the world come in and they just destroy trees for a week. They pull them, they break them, they explode them, and measure and see what it is. So here he is at a tree, and can't quite see it. You can see that obvious defect in the bottom there. And he's about to pull over the tree. And he's asked, keep in mind, these are the world-renowned experts in the field, to put a sticky note on where they think this tree is going to fail. And look at that variability. You can't see, I'm sorry. Trust me when I say there are sticky notes all over that tree. Okay, all the way from the bottom to the top. And I'm like, he's presenting this. This is at the ISA conference in Sweden. He's presenting this, and I'm like, if these researchers can't even agree where this tree is going to fail, how are we supposed to know where this tree is going to fail? Like, come on. So it's incredibly subjective. So I want to pick on this tree for a little bit. I was doing a tree inventory in Johnson, Iowa. It's okay to say that because you guys don't know where it's at. And I find this ash tree, okay? And I come across it, and looks pretty good. And then I get to it, and it's got this huge split. It's got a cable up in it. It's got a brace in it. It's actively being treated for disease in the community. So by a show of hands, I'd like you guys to indulge me in rating the condition of this tree. So who thinks this tree is dead? All right, good. We've got a good calibration as far as anything. We all agree on something. Okay. Who thinks this tree is in poor condition? Who would say it's in fair condition? And who would say it's in good condition? And who would say it's in excellent condition? Good, another calibration point. Okay. So, and who doesn't know? Who's just like, I know. I mean, look at that. That's a pretty average bell curve of every assessment that happens out there. And I would say you're all right. Yeah, there is no right answer to that point. And we can all agree. I bet if we had condition, we all stood, we had debates. I bet I can get some people to move, right? Tell my story. But there's going to be some people who's grounded in their beliefs, and that's totally fine. And what the problem is you're dealing with your knowledge base. You only know what you know. You don't know everything there is, right? That's just infallible humanity. And you're bringing to that your education from schooling or wherever. You're bringing your real world experience to that. You're bringing your knowledge of what an ash tree should look like. and you're bringing your bias to what you think an ash tree is kind of worth. You know? So I've beat that horse. All right. Now let's kind of end this with our current feedback on trees as it sits today. So kind of the industry average, if you were to find one according to the ISA BMPs. And Andrew said that Florida, how often? Listen, good job. So, you know, the industry average is somewhere around 5 to 7 is what they recommend the feedback on re-inspecting of trees. So in Buffalo, New York, we were hired to every single tree point that existed in their inventory and update the records for that tree. And it was on a 13-year cycle. So here's just some high-level findings. This isn't the point of the slide, other than the one thing I do like to point out is that, you know, they did a lot of removals, they did a lot of planting, and their total canopy still declined. So one of again, my wife is way smarter than me, and she likes to remind me, Josh, you cannot out-exercise a bad diet. Stop drinking the IPAs if you want to look good, right? Like, you gotta eat healthy someday. So, but when you start looking at condition, okay, so keep in mind, every single tree on this assessment had the exact point pulled up, we looked at the chip condition, and we said how it changed from the last assessment, this assessment. And when I started looking at the pivot tables on this and looking at it, I was like, whoa, this I found fascinating. So in 2001, there's 38,000 trees rated as fair. And in 2014, 300 of them had died. 1,400 of them had been removed and planted, or were just a planting site. But 5,300 of them had been removed and replanted with a whole new tree. So that, you know, that's pretty crazy. In my mind, when you look at the good trees, you see the same thing there. About the same amount of them died, and it's tracking very similarly. Now, when you look at this compared to the poor trees, like, I found that fascinating. You know, like, so what does this tell you? What do you think about that? Weren't rated well? Maybe. I know for a fact they weren't the same arborists looking at a tree. An inventory arborist that sticks around for 13 years is got mental problems. I'm just sorry. I shouldn't say that. Right. It's subjective. And the different arborists making different opinions at different times. So it is also kind of cool, though, that some poor trees can go to good or fair. They improved, you know. One of the things I like to think about here too is that poor trees stood around a lot longer than anybody thought they were. Like, they were recommended for removal. They could just never get to them, you know, and they were still there. So what that means is that they were providing oxygen. They were intercepting stormwater. They were reducing air temperature. They were providing ecosystem services, even though they were in a poor condition. And they did not kill anybody. They did not cause any damage to property. They did not interrupt any services. They're still there doing their thing. All right. So let's talk about what you really want to care about, the technology. But maybe I made my case a little bit. So some individual tree technology here. So this is a company called Adbian. They're based out of the Czech Republic. I don't quite endorse it yet, but we are evaluating this technology. And what Andrew was talking about a little bit, he didn't quite go into it, is looking at the biomechanical structure of a tree and thinking about the wind sail of a tree. And, you know, we know the tree elasticity. Almost every single tree has been measured. So if we think about the height of the tree and the canopy of the tree, and we think about the wind direction, we can start thinking about how stable is that tree. So this is a tree that I love this tree. You look at the size of this American elm. This is huge. It's not treated. I knocked on this stranger's door and said, I love your tree. Can I scan your tree? And I'm having a 20-minute conversation about trees, but this is a cavity that is, and I'm just amazed by it. So here's how this works. It's using your phone, just your standard iPhone Pro. You walk up to your tree and you scan the tree. And here's me scanning this tree. So I'm walking through and scanning the cavity of the tree. And I'm doing a 360. And what you'll notice is I'm kind of going up and down because it has a little grid. And I'm playing the color palette, right? Paint by numbers is what I'm doing. So. And it takes about a minute to do this. So as it gets done, then what you end up with is this 3D model of your tree. So here's a screen recording of my iPhone. And this is the output from the tree. So, your iPhone Pros have this is using the built-in LiDAR unit within your phone. So you can see I'm able to spin it, able to zoom in and out, I'm able to turn it around and get a good measurement of this tree. Combine that with 5 photos of the tree. So you take 3 photos of the stem of the tree, and then you take 2 photos of the entire canopy of the tree, and you measure the height of the tree, and you measure the distance from your photos. You measure the diameter. And what it's doing is it's calculating for you. You can see how it draws in the wind sail. And with the species, it's calculating something called a safety factor. So keep that in mind in a little bit. But essentially, we put it onto a scale, and it tells you how strong that tree is. So this tree comes in at about 140%. So below 100% means it's imminently weak and could fail. We like to keep it at around 150%, overbuild it a little bit, right? But it can go up even higher. And then every 10 centimeters, using your LiDAR, it takes a snapshot and it builds this structure of the tree. And it shows you what the tree looks like. And it finds the weakest point on the tree. So for this tree, it comes in at 2.3 meters. So that under normal conditions, normal wind speeds, that's the most likely place of failure. So how is this used? So this is where we would go in then and do our demography assessments on it. So we look up our demography, and that is probably the best place to put your demography. What this is missing, though, is any sort of root assessments. Okay, it's just looking at the tree has perfect roots. So if you're really interested in that tree, then I would recommend using ground penetrating radar. And this is really cool technology that's been out for a while, but recently there's been a couple of manufacturers that have specialized in trees, and they're able to just focus on like the top 30 inches and find the tree roots underneath the ground. So here we are using it at a tree in DC. So and this is a tree that we really want to preserve. And in order to help preserve it, we're mapping the tree roots so we know which roots and which areas are better to disturb. Or if you can preserve it, because too much root disturbance might happen. But you can combine this with that assessment and get the stability score. And what we're trying to do here is trying to move the conversation away from, I need to remove that tree because it's scary, to how can I prune this tree to make it safer? And looking at the results of your LiDAR scan and the results of your topography, you can start to calculate how much of the crown can you reduce to bring it into the threshold that you're comfortable with. Ultimately, everybody has to make their own decision on your comfort of risk, of course. But that's what the conversation is trying to center around. That make sense? Yeah. Radar. What are you measuring? To your factors for tree or chance of tree falling. Right? Yeah. So we use the density of tree roots and the size of tree roots and the location. You know? But there isn't good. That's why I say like we're evaluating this. This is kind of like Adiban's really proud of it. Our institute, we're testing it, we have pilots going, projects on it. We don't really know exactly how to bring in the root information with the tree information, you know. So it's that kind of art and science of it right now. It's saying, okay, based off of what we know of tree roots, does the size of this tree have enough roots? Yeah. Well, we can't tell if the tree roots are dead. Okay, so the next piece of technology that has been out there, and you know, it's kind of interesting during COVID. Like, while we were all bunkered down and thinking about our trees and trying to catch up on work, and that we never did catch up on, we got stuck in Zoom meetings. This whole crop of really smart engineers were sitting in the garages tinkering, thinking about trees, and that's where this Advian app came from. You know, I don't know why. So there's a whole crop of engineers out there looking at tree sensors right now. And there's about 4 good kind of companies. We've been working with Microsoft for about 10 years now in developing some sensors. And, you know, they're really interested in this Internet of Things idea. So here, as you can see, this is the size of one of the sensors that would go in the ground, checking mainly for soil moisture and soil salinity. But there's this other company called ePlant that has a sensor on the market. They have a little micro plunger screw that set on the tree. It can measure the change in the tree and the amount of phloem going up and down it instantaneously, because every time water goes up and down, the tree is just micro swells. So it can tell if the tree is actually moving nutrients. So, real promising. So, and there's sensors as well that you can put into the canopy of a tree and measure the tilt of it, see if it's changing, or how much it's swaying. So you can get normal sway, and you can get alerts if they start to sway more, or if it starts to tilt. And this becomes really important. So here's a project we have up in Minneapolis right now. It's really looking at the salinity. It's something you all aren't used to, but they have to salt a lot of their roads up there. So they get a lot of road salt for the ice. And so they have this out and they're checking it. And you can get real-time readings of it, but you can also get like a weekly average or a monthly average of that. Yeah.
You said ambient app? Is that attached to the sensor?
No, that's poor segue. And then you can look at it over like a month or something. So you want to look at trend lines or trends, what's happening out there. So I've heard a little bit about some drought last year that happened here. You know, I don't know if you need a sensor to tell you that drought's happening, but if you had sensors on key trees that you are worried about, it could give you an idea of what that soil moisture is. And have an idea of when to plant trees. Los Angeles right now is using tree sensors to measure the efficacy of tree watering programs. So they have a big city, lots of trees, and they have they have 8 nonprofits that plant trees on their streets. And it's a combination of volunteers, contractors, and in-house staff. So they have sensors around to determine which watering program is the best way to water their trees. Is it volunteers, is it in-house staff, or is it contractors? So the results aren't in from that yet, but that's how they're using it. All right, so that's a little bit of technology around the individual tree. Now I want to kind of go about, zoom out to urban forest. Andrew, this was, again, these aren't in your slide deck there because Andrew talked about the power of a tree inventory. So it is really powerful to know what you have, where it is, and what you can do, right? But if you combine that with the canopy study, it becomes even more powerful. And if you want to zoom in on under canopy areas, you can isolate those. And then if you want to look at your species diversity within those areas, you can hover around and you can get a quick snapshot of what that species diversity is there. And then you can find out what our top species of trees are. So a lot of times when we think about Minneapolis is doing, I'm sorry, St. Paul is doing an amazing job at this, where they're really thinking about tree diversity at the neighborhood level, not thinking about it at the community level, because they had to deal with EAV, and they had to lose about 15% of their population, and they recognized that certain neighborhoods were completely deforested, they were 100% ash. So they have a really robust species diversity goal at a neighborhood level, and even take it to individual street levels. So when you think about resiliency in urban forest, Andrew said that the most important thing you can have is a diverse urban forest. So we've been working really hard, a couple other people are as well, on this concept of smart tree inventories using ground-based LiDAR and high-resolution imagery to drive around streets and scan through parks. So like I mentioned, during COVID, these really smart engineers are sitting around thinking about trees. There's a company called Greenhill, which is based out of Budapest, who's working in Singapore with this idea, and it's creating these digital twins of urban forests specifically for trees. So when you look at this image, you can easily see trees. You can easily see stoplights. You can easily see cars. When you throw that into a computer, all it sees is zeros and ones. So we have to program our computers through machine learning to fly through this data set and isolate an individual tree. And that's really hard to do because in an urban environment, there's a lot of vertical structures. It's hard to tell a tree from a light post, from a building. But once we do that, we combine it with high resolution imagery and satellite imagery. We throw it into our supercomputer, and with artificial intelligence, we're able to extract that tree and then create this digital twin of it. And we're able to start extracting information about that tree. So we can get the species of the tree, we can get exact size down to the centimeter of the diameter and the height of the canopy. We can also look at things like the area index, so we can calculate how many leaves there are on the tree, which can help with light crown ratio. And we can calculate the dieback of the tree. So it was, Andrew and I are approaching this from the same perspective of what are the key metrics that go into evaluating the health and risk and the structure of a tree. So we can also think like leaning angle, as you mentioned. We can also look at clearance issues. But more importantly, we can also use this big data to put the trees into a cohort and manage them over time. So what that means is we take trees of the same species, of the same size category, and we put them together in this cohort, and we run analysis on it, looking for outliers. So here's the assessment. So you can see we have 6 things that we're measuring on. So like diameter, leaf area, height, crown width, and we're running against all these trees. So the middle here is average. You can see where all the trees fall for each one of those intersections. And then each tree is placed. So we're able to scan the entire urban forest and then find these outliers and then go out and inspect just those trees. So when you're doing a tree assessment, I mentioned earlier the inefficiency of walking to every single tree and the subjectivity involved with that. We don't have to go and evaluate every 3-inch newly planted maple because it just happens to be on the city's line. You know where it is. We're focusing our time on those waterworks that are declining or those dead pine trees or whatever from the drought, right? And that's done with a combination remotely in the field. I'll show you that in a second. So here's how that works. We get all the data at once, find those outliers. Make sense? So let's dive in a little bit more. And again, it's that idea that we want to make the right decision, the right tree at the right time. So I mentioned that inflection point between software and hardware. One of the reasons this is possible is every day that we collect data, we collect over 1 terabyte of data. So we physically have to move that data. That takes a huge amount of bandwidth and a huge amount of computer processing power. And then we got to have the computer strong enough for it. Well, all that processing, LiDAR's been around for a long time, right? Traditionally, though, when you get LiDAR done, have to process all that. It can take a really long time. What you get back is a bunch of dots on a map with a bunch of beautiful attributes. You don't get any kind of twins because viewing it takes a lot of computer power. So now, web-based portal, you can just go and you can view your twin and photos. And here's where you can see get real precision on the diagram. We can find individual dead limbs for you. So let's put this in the real world whenever we're going to look at our entire, this is the city of Pittsburgh. You can see on the snap where the trees are. And if I get a filter for trees that are outliers based on the leaf area index, it highlights, this is one of the trees it highlights. So I bring it up, and I can look at the twin. And now from the desktop, I'm able to look at the full 360 of that tree. I can look at the photos that were captured for it. I can see the dead wood that's there. Also create a new street view of it. So you can pan around and you can see the entire surrounding landscape of what that looks like. So more importantly though, it's not just a snapshot in time. I can look at it and see how this tree has been performing over time. So I can see, has it stable? Has that decline been there for a long time? If so, it's probably not that big of a deal. It is what it is. If it's new, and the last scan, last inventory showed no dieback, then I got an issue. Maybe I need to look at it. Maybe there's a bigger problem happening. So I can schedule an inspection to go out in the field and do that. So when I send out my field crew, Google, I can show them exactly what I want them to look at, what branches, what the issue is I want to deal with. So we were talking earlier about the safety factor, the trees to fall over, because we have really precise information on the species of the tree, the diameter of the tree. We know the slenderness of the tree, so we know the taper of the tree. And we know the overall crown. We're able to do that on a population level. So we can, what I'm showing you here is mimicking different wind speeds. So I can see that at a certain wind speed, this tree will become unstable and have a high likelihood of complete tray failure. So right now at 50 miles an hour is when this tree would potentially fall over. And when I look at it, I can see the tree fall over. I can see the exact leaning angle there, so I can see this tree is at 4.5 degrees. Again, looking at why that tree might fall over and putting it into the context of, oh man, this is next to some power lines, this is next to a house. I probably need to elevate that concern. Yes. Yes. It has the chance of falling over. It has not fallen over yet. No, these are all trees breaking at ground level. Don't put words in my mouth. Didn't break yet. It could break. Yes.
Okay. Is there any data that show the history of like brands that have been to show what the tree has already sustained? So it's like continuing up.
And this is part of what Andrew was talking about, right? He doesn't have enough data. He's trying to get more data. So, for every city that we scan, we have what we think is breaking point of the tree based on point out, well, this is the data, right? This is still testing. Part of it is having data on it. What I'm most interested in is looking at historical weather evidence and seeing what trees survived this storm and why did they survive. It's interesting that Andrew was talking about the defects and failures. I was just talking with Darren about this. Like, I've been very passionate for a while, but I think arborists are pretty good at knowing why a tree is going to fail. Although Andrew just proved we're not, but I like to think that we are. We just don't know when it's going to fail. And it's really surprising when you walk around and you look at it. You made a point, like trees with included bark are still standing. They haven't failed yet, and we should have, by all of our trainings, it should have failed by now. That's the conversation I'm really interested in having. When we look at trees and we see which ones are surviving, and we look at throwing in hundreds of thousands of data points, I think we'll have a much better story. And the real power of AI, the whole way ChatGPT works, is trying to use statistics to predict the next letter that you need. If we can get better at predicting tree failure through AI, that's a game changer in my opinion. We only get that by having more data in our models. And it has to be the same data. And it has to be objective, it has to be repeatable, it has to be precise. I'd like to throw in efficiency for saying that you guys it's a little crazy out there right now. Yeah, so that is my case for why machine learning and technology can be really important here. Oh, that was a nice 5-minute warning. In our world right now, tree equity is a really important thing, thankfully, right? It's a great conversation that we were having. What I'd like to kind of think about is, now that we're able to capture really precise candidate information on the trees, and we know the exact leaf area of it, we've had to reverse engineer iTree to calculate the benefits they provide, ecosystem services, and we can model that and look at as it relates to humans. So there's this concept of human thermal comfort, or we can also look at it around stormwater, we can look at it around pollen, other aspects of trees. We can see how it affects humans. And I would like to think machine learning, I'm afraid of this happening in our tree systems, is implicit bias for trees. I'm a product of the 90s that kind of grew up with Tupac. This is one of his poems that I love. I'd like to stop celebrating the rose that's growing through the concrete and make sure that we have fertile beds for all of our roses to grow, that all of our trees are doing as well as they could, regardless of the landscape that they happen to be placed in or that we plant them in, and that we do a better job at taking care of them and maintaining them for generations to come, right? So with that, I thank you for your time. Looks like everybody stayed awake. I appreciate that. Here is the link to the newest, latest slides if you want. And I think I might have like 2 minutes for questions.